Hello, good evening. Let me see if this got me the right place. Yes. Okay, so welcome to week two, and this combustion control is T101, and we will touch base on a lot of controls, and we'll try to transition into oil burner controls so I can start to prep you to study for the Massachusetts oil burner license uh, exam, but we will still touch base on some controls back and forth. And again, this course is combustion control circuits. So we're talking about several controls that goes into heating and cooling and using either gas or oil. So I did not want to emphasize more on the control part, but mostly of the components and how they function, because eventually you will do HVAC electrical application, which will again touch base on all these little controls and thermostat, but it doesn't hurt to go over them again. And as you can see in my camera here, I have my book open on chapter 12, which talks about thermostat, pressure switches, and electric control devices. Chapter 13 goes into more control, and 14 as well. We'll go over some of these aspects slowly as we go along. And I have some stuff here in the PowerPoint to also talk about. So, basic electronic control fundamentals. This is chapter 12 and 13. So chapter 12 here, I'm gonna switch into my camera. If you look at chapter 12 over here, I don't know if you can see it, if it's close enough. It's thermostat, pressure switches, and control devices. And if you glance over this, it will talk about how do we go from line voltage to control voltage. How do we get inputs and outputs? Thermostat is mostly the input for most of our decision making for controls. Different type of thermostat. I don't think you need to know all these types of thermostat and how they function. A lot of these things are almost obsolete. We mostly rely now on digital thermostat, and this explains here the idea of bimetal. So it is worthwhile for you to go over it and skim, but there's not a lot of information that you really need to fixate on, except for knowing how does thermostat function. Most of thermostat are digital. The heat anticipator, I don't even think this is applicable anymore. But if you see here, this is let me get closer. If you can see it, this is a picture of the heat anticipator, which basically it tries to predict the current of the heat generated by the current going to the thermostat, so it will not be a problem. But it's not something you really have to worry about that much. So it goes a little bit too much into setting for these old technologies that you don't need that much. That's why I did not want to spend too much time into all these old thermostat. You see, still coming to thermostat, programmable thermostat again. When it comes to programmable thermostat, it goes by the model. So there is no general way to know how to program a thermostat unless you know that specific model. So it's not really something you should worry about right now to learn, because it's very intuitive, and once you buy a programmable thermostat, you have to know how to use its own manual. Pressure switches, different types, the manuals and the digital. Uh, there's a few actually interesting ones here if you are interested into learning about pressure switches, timers. They give examples for some service calls. You can check it out if you want to. And that's basically what chapter 12 goes through, thermostat pressure switches. So you can, if you have the time and you feel like you're interested in knowing more about them, you can skim through the chapter. And again, this book is very good read. It's also very well put together. Chapter 13 is electronic control devices. Again, it goes a little bit too much into the control and some terminology that we don't need to know about for our intended purposes. We're not going to be making those little boards. We just want to know how they function. So it goes over, if you can see over here, rectifiers, uh, transistors, triacs, varistors, and all these kind of small little electronic device, which I don't think is very productive for us to know about all these little components. But again, it's very useful for you to go and skim through it if you would like to know some electronics. For chapter 14, which is actually very, very important, and that kind of substitute the Weinberger book information about heating and cooling controls. So if you want to actually spend some time reading something this week, go and try to read chapter 14. Other than that, try to keep it as simple as possible. We, again, as I said, basic electronic controls fundamentals, that's chapter 12, 13, and heating oil fundamentals. We're gonna start to move into heating oil controls, and that's the Nora book, which I actually require you to have for this class, and also is available on Blackboard. Also, as a reference, you can use Weinberger's book, the oil heat, oil burner heat. That book, I said, it's optional, but it's not mandatory to have. All right, moving on. So today we'll talk about basic control components. What are the burner functions? We will list common types of controls available in heating and cooling. What are the main controls that we need and that we will see, regardless of what they look like and what is the manufacturer and what are the variety. It's good to know and identify what controls are there, and when you go and try to see an oil burner or a gas burner, it's good to look at the system and see where are those controls and what do they do. Correlate the burner functions with the required control. And if you're taking any system lab 2, probably you've seen that, okay, we have an aquastat, we have a primary control, these things try to do these functions. How do we decide when do we turn on the burner? When do we turn on the motor? When do we start the motor? All of these sequence of operation can be controlled based on the input that we have. Then we will move to fuel oil, and that will be at the end of the presentation. So types of control. Again, we try to control the temperature. We can control air and water flow. We can also provide timing, pressure, flame level, light sensors, motion sensor. These are all controls. Some of these are inputs. But what is the main point of having these controls is we want to have the smooth operation. We want things to run the way we want them within our limits. And if you want to think of control in a very simple way, is think of yourself when you're trying to drive the car. You're trying to drive a car and you're in the highway, and what are you controlling? You're controlling the speed. And how do you control that? You keep your eye on the dashboard and you look at the odometer or the speedometer, and that's your input. You look at the speed and you process that speed, and you either change your foot pressure on the gas pedal, or you can increase or decrease the gas level on your cruise control. So think of that as what you try to control with your oil heat or gas heat. So you have some input, and based on that input, you process that into something else. So again, when you try to turn, you see the curvature coming in the highway. That's your visual input tells you that there's a curvature. You process that, then you start turning the wheel, and the wheel will start turning, the steering wheel, and the steering wheel will start to turn your tires. So again, there's always some kind of input. There's a processing center, and there's an output. So for temperature, to control the temperature inside the house, you must need the sensor. That is your thermostat. The sensor tells you that you need heat. That information will go into the temperature in your room, will go through the thermostat, and the thermostat will tell you, okay, this temperature is not enough, we need more heat. This will go again into the aquastat if you have a hot water system, and we will ask the aquastat to heat more water to supply heat, and this information will transport all the way to the burner and will turn on your heat. So again, it's a process of what input and output. And by doing so, probably you have realized that you need three things. You need to have input, process, second, then output to keep things under control. These are examples here for controls, and I just want to give you the approach of what's happening and what do we need to have this kind of control and how can we control things. And again, at the end, we did move on from having things done by a person to have it done more electronically and automated. Again, chapter 13 has more order controls, and some of the examples in the Weinberger book is liquid level, liquid temperature, steam pressure, air temperature, air movement, and oil burner flame. So all these controls are all working together to have the proper safe operation of the oil burner. This is an example of water level control. They are one of the most important controls because low water level is one of the main causes of boilers breaking, going out of function. So again, different types that will work either electronically or mechanically to control your water level. Steam pressure control. Uh, Again, from chapter 12 here, you've seen that there are pressure sensors, and if you took power plant operation, probably you've seen that we control the entire function of a steam plant by measuring steam pressure. We use solenoids and diaphragms, and also we control the excess pressure using relief valves and cutoff switches. For hot water, there's also, this is one of the most common mean to measure water temperature until recently, the aquastat, which has a bulb. This is the bulb inside, and it's filled with liquid, and this liquid expands through the capillary to control based on the control temperature and diaphragm here. So it will either turn on or off a switch based on the temperature provided by this expansion in the capillary tube. Again, aquastat is a Honeywell trademark. You can see a lot of those water temperature gauges. Some of them called aquastat, some of them called hydrostat. Just different name for the same function. Also known as the remote bulb thermostat. Liquid expansion, we talked about that. Okay. Air temperature, which is the thermostat. This is done. Let me just fix this quickly. Okay. This is something actually you would have seen a lot now in chapter 12, and I just went through it, which is the snap action or the bimetal of thermostat. Again, this is very, very old technology, but it's still being used, where you have a bimetal, that bimetal expands and contract, and it provides this. There's a magnet here that can attract that piece of metal to provide that snap action. Before that, there used to be mercury bulb, but that has been banned recently, so now we have to use a magnet. The reason being is this: if this metal contracts very slowly, what happens is if it doesn't snap, you will have more possibility of arc. You still have 24 volts, and they can use an arc, and that's not something that you want to have in a living space. They also digital thermometer or thermostat. They have less moving parts, and they use using thermocouples that measure voltage. We learned recently thermocouples and how they work, and they do produce voltage to be measured by a device to give you what is the temperature corresponding to that voltage. This is some of the controls for oil burners, and what we're looking at here is stack mounted control. So this tube over here is let me see, hold on. Pen. This here is stuck inside the flue pipe, and it has a bimetal inside that will expand with heat, and we will detect the presence of flame inside by the heat, and they are still in business. We use them for systems that are grandfathered in, and we use them also for detecting temperature, but they are no longer the code to be used to detect flame. However, if they're still there, you can keep using them. They work on the basis of uh, they work based on the heat that's coming out of the flue pipe. Let me fix this a little bit again. Score. A second. Okay. Okay. This is what it looks like. It's still there. It's supposed to be used instead of the of the Catsail control. Uh, Going back to the book here, chapter 14, heating fundamentals, heating control. Again, I hope you still have this book. And here you see we still have the stack control, but this here is used as a limit switch. It's not used as a mean to detect flame, so it's still there. These fan limit switches are very important to understand, which is the same function as this stack control. It goes into the stack and it turns on a switch once the temperature reaches a limit. I hope you can see it here. So it's 14.8. I don't know if you have the same version. This is the 9th edition. So the function of these control here, as it's illustrated, is to measure the temperature of the air passing through. And based on that, it will turn on or off a switch, which is a very good advantage to have when you have hot air system. Uh, some of them come with timers as well, as you can see here, and they operate a lot of fan motor switches. This is really good. This is a pressure switch and it's used in gas furnaces. You'll see this a lot. Once you turn on your gas burner, this will indicate that there is flow in your pipe. You will not want to. So first you turn on the fan and you open the flue pipe. If there's the proper negative pressure, then the gas will turn on. So this is a very important switch to have. It's a diaphragm and it's on and off to indicate that there's a flow in the system. Thermocouples, again, picture of thermocouples that can be used to detect heat. Some of these are gas. We will do one lab about gas furnaces because gas is becoming more and more common than oil in Massachusetts. Here you see some ignition electrodes. Again, there's not a lot of oil being discussed in this chapter for some reason. That's why I referred to the Weinberger book. But we'll cover a lot of oil heat when we do Nora book. So yeah, this is the Catsail. We did that. So there is some interesting information here, but the book does go a little bit in kind of details that not necessary, but it doesn't hurt to skim over it. Hydronic and steam controls, we will do that as well, and a few service calls. Okay, so that's pertaining the book for now. I think if you just skim over it, you'll be okay. And Nora book had a lot of information about oil heat, which is more valuable to us than uh, gas, because again, oil does break more than gas and require more maintenance. All right, let's move on. Catsail primary control, that's the control that does all the operation in your oil burner. It uses cadmium sulfide to detect light. When there's no light, no flow of electricity takes place because in the darkness the resistance is very, very high. 15 to 45 seconds delay. We talked about that. There's a PV cell that can detect light, but PV operates differently than Catsail. Catsail changes resistance. The photovoltaic in the PV cell produce voltage, so that's different. There's also infrared detectors, and those detect different waves of light in the flame. Thermocouples, they produce voltage. So these are all ways to detect heat and light. We try to use the one board system that I'm gonna move this here. The one board system is all the control and all of those switches being combined into one board. Uh, what does that mean? That means that our relays, our logic, our timers are all combined to one chip of silicon with all the components on it. And these are our connections. So you can now get one board that will do all the processing that you need without all these complications. Once you go into building automation and bigger control, you'll see that you can get more sophisticated control that all being combined together. If you go into those TACO control switchboards, they have all the inputs in them and all the sensors, and things became less bulkier and more concise and also more effective. So you'll see those old switches the way they were before, since the 60s or 70s, but they're getting more advanced, and you will see one board with all the inputs coming into it and the processing already been done, and some of them have also computer interface as well. Okay. Simple electronic temperature control. We can control temperature using either uh, thermistors. Thermistors do measure resistance by measure temperature by changing resistance, and thermistors are used mostly for cooling. For heating, we use thermocouples. Yeah, we have a lot of solid states, not a lot of moving parts. The primary controls and the aquastats, the old ones had moving relays with mechanical linkage. The new ones are mostly solid states, and sometimes you don't even see the relay. So solid states with no moving part became more dominant now. Uh, Electronic timers, again, as we've seen in the one board thing, the timer becomes small integrated circuit component, and there is no need for like mechanical relays or mechanical timers. But I will show you some controls later in this class where even the timers and the sequence of operation is done completely mechanically through camshafts. It's very interesting. Okay, so we'll move on now to oil and oil controls and some codes, but I hope you'll be able to skim over the book and keep those information with you in mind, because we will be using them as we go along, which is how do we control pressure, how do we control temperature, and how do we sense, how do we process and control. So sensing is getting the information. Controlling is how to process the logic, what you want to happen, and the output is the actual control. So you sense the temperature with the thermostat, the aquastat will do the decision, and you can turn off and on the heat using the primary Catsail control. So actions always happen. Okay. Heating oil and its properties. Fossil fuel has been one of actually the most dominant source of fuel for the last 100 years or so, and it's going to be for still a long time. There's no way around it anytime soon, but we are trying to phase it out slowly. So fossil fuel is very diverse, and it's used for generating power or generating temperature or for just heating houses, and sometimes also for transportation. So some history here. Petroleum is a Greek word, means the oil of the rocks. It's been around again for hundreds of years. And again, it's a fossilized fuel, which is organic matters that have been stored in rocks for millions of years, over 150 million years ago. And again, there are ways to make some kind of similar fuel oil that are not as fermented and from current resources. The oil is lighter than water, so this is some of the things that we have to think about. So whenever you have water and oil will always float. And again, all oil products are composite of hydrocarbon, which is hydrogen and carbon. So again, organic matter needs carbon. Fossil fuel is organic. It came from fossilized material, so it has hydrocarbon. How long would it last? New types of oil products and renewable oil products. How long would it last? I think we already passed our peak oil, which is the access to easy fossil fuel, and we have to be creative to get more fossil fuel. We're trying to get more types and trying to fracture more types and use hydrofracking using gas. We try to use whatever we can to extract all the oil we can from Earth, but it's not going to last for a long time, and we should use this easy fuel oil time or easy fossil fuel oil time to uh, be able to find other resources. Is there renewable oil products? Yes, there is. There is biofuel. There's a lot of organic ways, or I mean, renewable oil products. You can make biodiesel. You can make methane. You can make ethane. All of this fossil fuel, all of this oil. Sorry, all of this combustible material is available to be made on the spot. However, the issue with carbon gas and greenhouse gases is combustion. So combustion in general is not a good idea, whether it's fossil fuel or non-fossil fuel. So we try to go with something more green. Again, the definition of green is different than renewable. Just because it's renewable, you can burn a lot of wood, and that's renewable. But again, still you are producing a lot of greenhouse gases. So again, that's not our concern right now, but it's good to know the distinction between what is green and what is renewable. Fuel oil and sulfur. So that's another issue. Like fossil fuel has a lot of sulfur, and there's a lot of codes and regulation that says that we should not have sulfur with us as fuel. So Europe has no sulfur fuel oil. We have low sulfur fuel oil. Sulfur is bad because it can cause sulfuric acid, and sulfur is not a good material to have in the air, but it's actually a good fertilizer. But to stay focused, I want to say that, okay, there's also issues with, we're still burning fuel oil, which is made out of fossil fuel, so it still have some sulfur, and that's an issue we have to be aware of. Stable oil and fractured oil and storage issue. So that's something also you'll see in the NORA book. When you read the NORA book, you realize that this book is trying to propagate fossil fuel a lot. It has some kind of commercialism in it. So you have to be aware of that, but it's still, nevertheless, it's a really good book and have good information. But what they were saying that fuel oil is very stable in its natural form, and once you take the sulfur out of it, it becomes unstable. That's why storing oil for a long time make it decompose into something else, meaning that you cannot store oil for a long time if you have taken the sulfur out of it and in the form that it is in right now. The American Society of Testing and Material, they give the standards for how to store oil and what is the properties should be for to be able to sell oil or sell all these oil products. Sulfur oil. Properties. Okay, these are the things that we have to remember. Flash point is the maximum temperature at which the fuel can be safely stored and handled without a serious fire hazard. This is the flash point. It's when it starts to flash, evaporate, but not ignite. So remember that term. Vaporize, but not enough to support flame. For number 1 and number 2 fuel oil, it's 100 degrees Fahrenheit is the flash point. And again, check with the book for different kind of fuels. Ignition point is the temperature where the fuel will start to ignite and can sustain flame for at least 5 seconds. And that's 500 degrees for fuel oil. Pour point is the lowest point where the oil will start to flow, which is 20 Fahrenheit. Any lower than 20, then it will start to crystallize. So that will cause a problem for oil that's stored outside, or if you're in a basement that's really cold and the oil starts to crystallize, you might need to heat your basement if it's going to get lower than 20. And again, the temperature here in Massachusetts can drop more than a zero sometimes. So, and yeah, it could also be up to -7 or so some days. So you'll have to think about that. Cloud point, that's between 10 and 20, and that's when you start to have some crystallization in the oil. Viscosity, it's a property of the material, and it's kind of like how fluid it is and how viscous it is. This is viscosity, and viscosity decreases with heat and adding kerosene. So more viscous, that means more fluid, more liquidy. And high viscosity means very thick and gooey. So it decreases with heat or adding kerosene to the oil. More oil information, contamination. Water accumulation is a big issue for oil because it does promote the growth of sludge. We are allowed to have sludge in the oil by only 0.1%, according to Aston. Density of oil is 7.1 pounds per gallon, and it has 19 BTU per point and 139,000 BTU per gallon. Color, it's the commercial fuel oil is cranberry juice color. Why is it color? It's legal issue. They want to be cranberry juice color because the fuel oil used for trucks, which called diesel oil, is green, and they both are the same properties exactly. However, the fuel oil for heating is priced differently. It's cheaper than diesel, so the color is a big issue for people who drive trucks. If they use the cranberry juice color one into the trucks, they can tell and they get fined. So that's why the color is a big deal. You can add kerosene to make it more flowy. Do not add gasoline under any circumstances. That's a bad idea. Uh, Again, I've seen that happen. It's a bad idea. Tank problem. Fast pumping is an issue. Rust is a problem. Water is a problem. And also bacterial growth is a big issue for these kind of product. How to deal with the problem. If you have any kind of gumming or problem in the tank, you have to clean the tank, and there are some specialized company who do that. If you have water in the bed of the tank, you have to empty the tank and get rid of the water. Uh, Best practice in fuel storage. Use oil filter on every oil burner. Change that oil filter every season. Keep the tank clean. Avoid having water. You're gonna have water from the room. How is that? If, Whenever you take out oil, you're gonna bring in air. When you bring in air, air has some water coming with it. So eventually you'll have a lot of condensation, and this is how you have water. And also buy from a good source. Check the tank for water, remove any present water. Filters are sized based on the flow rate and pressure drop. So again, that's something you have to look at when you change those filters. Bypass filter to stop the system. There's always a bypass around the filter, so you can cut off the filter from the system and change the filter. If you see sludge in the filter, that's a sign that something is wrong. Always use new gasket. Use grease to keep it in place. Change annually. Check before season starts. Check with the manufacturer specification. Tie it with 270 degrees and 3/4 of a turn. Some information here about oil filters. Okay, that's all I have for you for this week. I know I threw a lot of information on you. Please take time to, okay, first, I want you to go and skim chapter 12 and 13 and get ready with Nora book and look at chapter 1. And next week we'll move on to more controls and more aspects of the oil burners and components. And please check Blackboard for the homework and discussion board. Thank you.